Hello everyone. So in this lecture we will be discussing about the string added distance or levenshtein distance. So what does this question ask? This question says that if we are given two strings, a source string and a target string, then we need to transform our s into t and with minimum number of operations. And what would be the operations that we can perform onto our source string? The operations which we can perform are a delete operation, an insert operation or a replacement operation. So we would be discussing about these operations in detail once we go to our recursive tree. So the minimum number of operations required to transform s into t is actually called the added distance between s and t. So in this example, if we see, what are we given? We are given a source string of horse and we are given a target string of rorse. So we need to have a function which returns 3 in this case. And what does this 3 signify? This 3 signifies that the minimum number of operations that need to be performed such that my horse becomes rorse are 3. So coming on to the operations, what are these operations? The first operation which we have performed on our source string is replacement of h. Then the second operation we have performed a removal of r. And in the third operation we have removed e, the last e present in rows. So we can see this is the way which we converted our source string into target string, and hence we will return 3 in this case. So I highly recommend you to just pause the video over here and take a look at how to create a recurrence relation for this one, because by now I think you are in a position to think about all these kind of problems. So if you want to just try it out, pause the video right now because I would be starting with the explanation now. Now coming on to our base cases and our recurrence relation, what do we see over here? We see that we do have some base cases and we also have some cases with the help of which we will create our recurrence relation. So now coming on to our recursive tree, what do we see over here? We have a source string of horse, we have a target string of rorse, and this is the method which will be returning the minimum number of operations that needs to be performed on the source string to convert into a target string. Now this s represents this one, so either it would be a pointer or a reference to my source string. Again, this t would be a pointer or a reference to my target string. This s underscore l signifies the length of my source string. This t underscore l signifies the length of my target string. This s underscore current index represents the current index which I am setting on in my source string, and this t underscore current index represents the current index in which I am setting on in my target string. So what would be my initial call over here? My initial call would be this one. What does this 4 signify? That currently I am at my 4th index in source string. And what does this 2 signify? That currently I am on my 2nd index in my target string. So what are the operations which we can perform? There are 3 operations: an insertion, a deletion and a replacement. So how do we simulate that? We will see over here. Now this is the branch for insertion, this is the branch for deletion, this is the branch for replacement. So how does our algorithm work? At each and every index which we are currently sitting on, what we would be doing is that we would be checking that whether the characters present at those indices are same or not. If they are same, then what would I be doing? I would be just telling, okay, these two characters are same, just recurse for the remaining strings in both the cases. Okay, we will see it over here. Now, if suppose I had this string, horses and rorse. So what does this signify? That I need to convert my this source string into this one. So what do I see? The first thing I would be doing in my recursive calls, I would be checking the last characters present over here. And what would I be looking into? That yeah, these both characters are same. So what to do now? So what am I left with in the source? If these two characters are same, so do I need to perform any operation in this case? No, because they both are same. So there is no need to convert this character of source into the last character in the target. So what do? I will just recurse for the remaining string. And what will I say? Okay, just tell me this, the last s of both the source and t are same. Just tell me what are the minimum number of operations which I need to perform to convert horse to arrow, to my remaining string of source into my remaining string of target. So I would be recursing for this thing. That's what I have done over here. If my characters match, so what would I be recursing for? I would be recursing for the remaining strings over here, n-1, m-1. Now, but in this case, do these characters match, e and s? No, they do not. Then what to do? Then I need to check what are the minimum number of operations I need to perform to convert my horse into rorse over here with the help of these three operations. So in the first branch, I would be doing an insertion operation. And how do I simulate that with the help of recursive call? Look, these are my original strings over here. Now, what am I saying? That this E is not equal to this S. So how do I convert my last character of source to my last character of target? So the first thing which I can do is I can insert, and what would I be inserting? For sure I would be inserting S, because if I need to make last character of S into last character of T, so I will insert an S over here. Then what happens? What would I be left with? I would be, these two characters I have made equal with the help of insertion. Then what am I left with? I am left with one less character in my source, because I only need to convert this arrow. This is my target left. And what am I left with in source? I am left with all the characters within the source. Look, because I inserted a character, I didn't do anything to my original string. Instead of replacing or deletion, I just inserted a character. So it elongated my string length of source by 1. So what would I be left with now? I am left with all the characters remaining in source and one less character in target. That's what I have simulated over here. I am sending the same index over here, 4, and what does this 4 and this 4, they both being same, signify that I did not even delete or replace even a single character in my source. I never changed it. I just elongated it by inserting a new character over here. So this 4 and this 4, being both, signify this thing. And what does this one signify? This one has been decremented from this 2, or how did I get this one? I just decremented a 1 from this 2 and I am left with 1. And what does this one signify? That now I need to only check for these two characters, because for this S I made them same in target and source by adding an S in my source string. So this call signifies this thing. This call says that okay, I am done with my last character of my target. Just tell me now what are the minimum number of operations to convert this string 0 to 4 into my target string of 0 to 1. That's what this call signifies. If you didn't understand, please rewind the video and check it once more. Now, what will happen if I delete the character? Look. Now, this is my original string which I am discussing about. The source string is horse and target string is rorse. So, if I need to delete a character, then what would I be doing? I will be checking whether, initially what I am doing always, that I check that whether the two characters are same or not. That's what I would be doing. No, they are not same. So, what would I be doing? I would be deleting E. So what am I left with now? I am left with one less character in source, but all the characters present in target. This is the way I have simulated that thing. What I have done? I have decremented 1 from my source, but the index of my target remains the same. And why did I decrement? Because I deleted E now. Again, I wouldn't be deleting it directly into the source. I am just doing simulations over here, because we are just asked that how many operations we need to perform. We do not need to change the source. We are just being asked that just tell me, if I try to change the source, then what are the minimum number of operations that I need to perform such that my source string becomes into target. That's why I wouldn't be changing anything neither in my source nor in my target. I would be just simulating all the calls, simulating my insertion, simulating my deletion, simulating my replacement. So what does this thing say? This thing says that I have deleted a character. That's why I would have come over here 3, because earlier I was at 4. But if I delete the character, but then also I'm left with all the characters in the target. Because why did I delete a character? Because both the characters in my source and target were not same. And hence, what did I do? I just deleted the character. And I would be left with my all of the target string, but one less character in my source. That's what I did over here. I am left with one less character in my source, but all the characters present in the target. Now coming on to the replacement operation. What do we do over here? Look, these are again my original strings. So again I will check, is this E equal to this S? No, it isn't. So what do? I need to make this E equal to this s. So I have performed insertion, I have performed deletion, now I need to perform replacement. So what will I replace e with? For sure I will replace e with an s, because that's what I need to convert into. So I made these both characters same. So what am I left with? I am left with again one less character in the source and one less character in the target. So after the replacement operation, when I made both the characters same, so what did it say? That okay, I have made the last character same. Now just tell me what are the minimum operations that need to be performed to convert my remaining characters in the source to remaining characters in my target. That's what I have done over here. I would be doing n minus 1 comma m minus 1. So this recursive call signifies that thing. And then I would be taking minimum of these, because look, what do I need? The minimum number of operations. So in my recurrence relation, I need to take the minimum of each and every path over here, because this would be a very big tree over here. So I would be having many branches. So each and every path in my recursive tree would be giving me an answer that okay, I need to have three operations, or say 3 deletions, or 3 replacements, or 2 insertions, 1 deletion, 2 replacement, 1 insertion. So each and every path in my recursive tree for sure will be equivalent to one of the combinations of these 3 things. So hence I will be taking minimum of those, and I would be adding 1 to it. Now why did I add 1 over here? Again, if I would be, whatever would be the answer to all these cases, but till now I have performed an operation. In this case I have already performed an insertion operation, otherwise my 2 wouldn't have become 1 over here. If look over here, what did I do initially? I was given these 2 strings. If I inserted a character to make my last character in both the strings same, so what would I have done? I would have added an s over here. So I have only added an s, but I have performed a single operation now. So whatever might be the case of converting this horse to arrow, but I have performed an operation, and hence I am adding 1 over here. So similar way we have performed an operation over here as well in the case of deletion. So in the case of deletion, what did we do? My both characters at last were not same. So what did I do? I just delete one of the characters, or the last character in my source. So what am I left with? That just tell me what are the minimum operations that need to be performed to convert one less character in my source, but all the characters in target. Whatever might be the case in that thing, but I have performed a deletion operation over here, and hence I would be adding 1 to it. Again, in the case of replacement, what did I do? I just replaced my last character with the last character present in target string. So whatever be the case to convert HORS into RO, but I have already done 1 operation. In this case, it was replacement operation. So if you see that in each and every case, I have done 1 operation. In this case, I did insertion. In this case, I did deletion. In this case, I did replacement. And hence, I am adding that 1 over here. This one signifies that thing, that I have already performed an operation. Just tell me with the remaining characters, what are the minimum number of operations that need to be performed. So if we branch out, say for this SE4,1, so what would it be doing? This is insertion, deletion, replacement. So in the case of insertion, I would be doing the same thing, SE4,0, the same what I did over here. If you want to see that how did this 4,1 came in from this 4,2, so please rewind the video and check it once. So the same thing I would be doing over here. I would be recursing for SE4,0, SE3,1 and SE3,0, and again I would be adding 1 over here. This one again, as we discussed, it would be the same, it has the same reason such as we had over here. Now in the case of SE4,0, I would be again recursing for 3 things. Either I insert, either I delete, or I replace. But I would be hitting my base cases over here. Why? What does this thing -1 say? This thing says that now I am out of my target string. And what is this path? Look, what was this one? This one said that I inserted a character. So insertion, insertion, insertion. So it means I have inserted RO, this thing. I have inserted ROS at the end of my string. Now what am I left with? I am left with all of my string but nothing in my target string. Because if I did 3 insertions, then what would be those insertions? For sure those insertions would be the insertions present in my target string. So I have created last 3 characters equal to the target string, but I have nothing left in my target string now. But my index would be again at 4 over here. Again I am currently at 4 because whatever characters I have inserted, I have done all those insertions after this string to convert into this string. So again I am left with 5 characters. So what would I be returning? I would be returning 5 over here. And why 5? Because now this has become equal to my target, but I am still left with something in my source, but I am not left anything in my target. So how do I convert something in source to nothing in target? By deleting all the remaining characters in source. That's how I convert my a source string which has some characters to an empty string in the target. So I performed 5 deletions. So that's what I would be returning. I would be returning 4 plus 1. So it is my this base case that I have something left in source but I have nothing left in target. So delete the remaining characters. Return remaining characters from source over here. So what would I be returning? I would be returning t current index plus 1, because how many characters do I need to delete? I need to delete 5 characters over here to convert it into an empty string. Currently what am I at? I am at 4. So this is the index. So I would be returning 5 characters that I need to delete 5 to get rorse into this rorse. Now what does this say? This says that I performed an insertion, but then I created a deletion. What does this path say? This path I am talking about, this says I performed an insertion, then I replaced a character over here. So again I would be hitting my bases in this thing. But again, what does this say? That now I am at index 3. So what do? I need to delete all these characters because I am nothing left in my target string. So what would I be returning? I would be returning 4. And what does that 4 signify? That 4 signifies the total number of characters which I have deleted in my source, such that my source string gets converted into target. The same way I would be recursing for 3, 1 as well. So I think you would have got an idea that how are we actually recursing over here and what is the recurrence relation. Again, the recurrence relation would be to take the minimum of all these operations. When I am inserting a character, so I would be recursing for this thing. When I delete a character, then I would be recursing for this thing. When I replace a character, then I would be recursing for this thing. And when my characters match, then what would I be recursing with? Again, we saw if I have this thing, horse and rorse. Now suppose if instead of this I would have got this, that my initial string would have been this thing. I am left with HORS. I have HORS in my source and I have ROS in my target. So what do? I just compare both the characters. They are same, yes. So if they both are same, so I need not perform even a single operation in this case because both the characters are same. So what would I be doing? I would be recursing for the remaining characters in source and the remaining characters in target. Means what are the minimum number of operations that I need to perform such that my HOR gets converted to RO, because again S and S are same in this case. So what would I be recursing for? I would be recursing for n-1 and m-1. N over here is my length of source, m over here is my length of target. So with the help of these base cases and these two cases, we created our recurrence relation and we can see a recursive tree over here. So before going on to the DP optimization, I highly recommend you to just branch out for each and every subproblem over here so that you will see the optimal substructure of this recursive algorithm and as well as the overlapping subproblems as well. So we do see overlapping subproblems over here such as SE30, SE31, SE31, SE30. So these are our overlapping subproblems. So we also see that we have optimal substructure because how did we get answer to our intended problem? With the help of all these subproblems, and then again we branched out for insertion, deletion and replacement for each and every subproblem until we hit our base cases. So we do see that we have optimal substructure and we have overlapping subproblems. So we can apply DP onto this recursive algorithm. So in the next lecture, we will see that how do we actually apply dynamic programming onto this recursive algorithm with the help of tabulation method. So meet you in next lecture. Till then, thank you.